Good morning, everyone. Welcome to the practical session of data structure using C. Um, Today we will learn the fourth number practical write a C program. Write a C program to search a particular data from the given array of the number using the binary search method. In this practical, we will learn how we can search the particular data using the binary search method. Binary search is one of the most efficient searching technique. It's work by repeatedly dividing the search space into the two half until the required element is found. However, binary search can only be applied on the sorted array. So it's most important that the binary search only work on sorted array. So the what is binary search? Binary search is a searching technique used to find an element in a sorted array. Instead of checking each element one by one like linear search, binary search compare the with the middle element target value with the middle element of the array. And how it's work, first is the find the middle element, then after if the middle element is equal to the search key, then the element is found. If the search key is the smaller than the middle element, search in the left half. If the search key is greater than the middle element, then search in the right half. Repeat the process until the element is found or search the space become empty. So now let's understand this concept using the example. So I take one example. In that example, I take one sorted array, some like 10, 20, 30, 40, 50, and 60. Okay, 170, 70, 80, and 90. Okay. Suppose we want to search the element is 70. If we want to search the element 70, the array we have array 10, 20, 30. Sorry, 10, 20, 30. We have that array, and that array have already have some indexing. Means 10 have 0 index, then 20 have 1 index, 32 and 43 and so on. They have some indexing. So now we want to, our first step is to find the middle element, and for finding the middle element we have a formula that mid equals to low plus high divided by 2. We have that formula. For that we need to find the low and high. So our low value is the low is the starting of the array, means 0 index, and the high is the end of the array. So our end of the array value is 8, 0, 1, 2, 3, 4, and 8. So our high value is 8. So we take 8. So now the middle value is low plus high, means 0 plus 8 is 0, and divided by 2 means the mid value is now 4. So the middle element is 4. Now we check ARR of mid. Mid means our 4 value. So mid ARR 4, and the ARR 4 value is, so our fourth element is 50, means 10 is 0, 1, 2, 3, and the fourth element is 50. So now our mid element is 50. Okay. So let's compare the mid with the key means which element we want to count. Our key is 17. Okay, so we need to compare the 70 with the middle. So 70 is greater than equals to 50. So now we need to search the right half. It means left half we skip. Left half means we skip the 10, 20, 30, and 40. We skip this 10, 20, 30, and 40. So now we check second half means right half. So now the we update the our value. So low value is become 5. 5 means it's come from mid, whatever our mid value. So mid plus 1 is our now low value, because we want to check the right half. And here we write that if the search element is if the search element is greater than middle element, then we search the right half. So here the lower value is now updated to 5, and our high value is not changed, it's still 8, because our last element is. So now the mid value equals to whatever our 5 plus 8 divided by 2. So 5 plus 8 divided by 2 equals to 6. So now our mid element is ARR of 6. So our ARR of 6, we need to check that 0, 1, 2, 3, 4, 5, 6. 6 means 70. So now our mid value So now our value is 70. Mid value is 70. So now we need to compare the our mid equals to key. So our mid value is 70 equals to and key is also 70. So element is found. Element is found. Now let's understand the program. So first of all, we take header file. The header file contains the standard input output functions such as printf and scanf. After that, we write here the main function. It is the entry point of our C program, and inside that program, now we build the our logic. So first of all, we take one array. The array size we take maximum size that 100, and another one is n, and the key, and the ARR of 100 is used to store the array element, and n is stored the number of element, how much number of element in the array, and key is used to store the search element, means which element we want to search. And sorry int low, high, and mid. So low is represent the starting index of the search range, high is represent the ending index of the search range, and the mid is store the middle index of the array. Found. Then next we need to take one another element is found. Found is for a status. It's a flag like it's initialized with 0. If the is initialized, it means the element is not found. If the it's updated the found value, then that means the element is found. After that, we write one message for user that enter the number of element enter the number of element, then scanf %d address of n. the user enter the how many element will want to store in the array. After that, again we say the user, means we ask the user to enter the element, enter the, and most important that we need sorted array. That's why we clearly instruct that user that enter the sorted array element. Okay. After that, we take one for loop to store the element into the array. So our starting index is 0 and it's going to up to n. Then I plus plus scanf percent d and address arr I. Okay. The loop is used to enter the array element into the, and it's stored into the array. The array must be a sorted array. After that, we give the, means we ask the user to enter the element to search, enter the element to search. Then scanf percent d and the address of key. Example, the user entered the 70th key. Now we need to initialize our value. Low is 0 and high is n minus 1. The low is point to the first element, and the high is pointing to the low element. Sorry, last element. That one is 0 and 8, for example. Then we take while. For in the while the condition is low is less than equals to high. What is the meaning of that? While the loop is continuous as long as there is the element left to the search. Means if the element is remaining, then the loop is execute. If the low become greater than high, it means the element is not present in the array. Inside that we find the middle value. So for the middle we have one formula, that low plus high divided by 2. We have that formula. This statement calculate the middle position of the current search range. After that, we check a condition. If ARR of mid, if ARR of mid equals to key, then we have, first of all we update our found value. That one, it's indicate, it's like a flag that give us a signal to element is found, element found. Okay. After that we break here, because if the element is found there, so there is no need to check after the element. If the element is not equals to the, not, if the element is not equals to, means key is not equals to the middle, then we check else. If the key is less than two middles, if the is less than, that means we need to change our high value. High value means we ignore the right side of the loop. So mid minus 1, mid minus 1. If the element is not less than key, that means the second one condition is it's greater than. So in else we write low equals to mid plus 1, means now we ignore the left side. After that we end our while loop, and after the while loop we check our found value is updated or not. If it's updated, that means the element is found. So if the found value is updated or it's not updated means the element is not found. So here we print, sorry, element is not found. So our program is done. Now we check the output of our program, means how it's work or not. So let's check. Here it's asked the enter the number of elements. So I enter 5 and enter the 5 element 10, 20, 30, 40, then 50, and enter the element. So I need to find, means key is 40. So element is found. If the element is not present in the list, so what is the output of that? 10, 20 and 30. The element we need to find that 50. So element is not found. Something like that. So our program is execute. Is change the mid value. After that, first of all it's compare the mid value with the key value. If it is not matched, then again it's check the, if the key value is less than mid value. Here we write that if the smaller than the mid value, then we search on left side. So search on left side means, if we want to search on left side, that means the high value will be changed. And if the key value is greater than the mid value, then we need to check on right side, so we update the mid value.